Hello students, welcome back to the next module of a chapter called electromagnetic induction, and again in this particular module we'll be discussing MCQs which are based on concept of alternating current and EMF, right? So let us start. The first MCQ says a LCR circuit is joined to a source of alternating EMF if R equal to 9 ohm, XL is equal to 28 ohm and value of XC it is equal to 16 ohm. Then the impedance of the circuit will be, and the options are option A 10 ohm, option B 15 ohm, option C 20 ohm and last option is 30 ohm. So students, over here we are provided with LCR series circuit, right? And in this case value of resistance, value of inductive reactance that is XL and value of capacitive reactance that is XC is provided to us. That means value of R, XL and XC is provided. And what we are supposed to find? Here we are supposed to find out the value of impedance. So students, what do you mean by impedance? It is nothing but the overall opposition which is provided by LCR series circuit to an AC source. And this impedance is represented by symbol Z, and we know the formula for Z. What is the formula for Z? Z is nothing but equal to square root of R square plus in bracket XL minus XC the whole square. Now see, we are provided with the value of R, XL and XC. So here we are supposed to find out the value of Z. Value of R is 9 ohms, right? Value of XL is 28 ohms and the value of XC is 16 ohms over here, right? So let us substitute the values. So Z it is equal to square root of 9 square plus in bracket 28 minus 16 the whole square. Now on further calculation we'll get Z it is equal to square root of 81 plus 144 and this will come out as square root of 225 which is nothing but equal to 15. So in this case the impedance of the LCR series circuit is 15 ohms, right? So which option is correct? Yes, option B is the correct answer. Now let us move further. Let us start with the next MCQ. It says if an alternating EMF is applied to LR circuit, so here capacitor is missing. That means the value of XC will become 0. So if an alternating EMF is applied to a series LR circuit, the phase angle between EMF and current is theta. Then we are supposed to calculate the value of tan theta. And the options are option A omega L by R, option B R by omega L, option C L by R and option D is R by L. Now students, we have already learned from LCR circuit that tan theta or tan phi, it is given by the formula XL minus XC upon R. Do you remember? This we have taken out from the phasor diagram, right? Now students, see carefully. This is a LR circuit. Now as it is a LR circuit, the value of XC will be equal to 0. And we also know that XL is also given by the formula omega into L, where omega is angular frequency, right? So if I substitute these values in the above equation, so what will I get? I'll get tan theta, XL will be replaced by omega L, XC will become 0. So this will give me tan theta, it is equal to omega L upon R. Now see carefully which option is matching. Yes, option A is the correct answer in this particular situation, right? Now let us move further. Next MCQ, it says what is the phase difference between virtual current and virtual voltage when the current in the circuit is wattless? And the options are option A 180 degree, option B 45 degree, option C 60 degree and last option is 90 degree. Now over here I want to find phase difference between virtual current and virtual voltage. Now what do you mean by virtual current? It is nothing but IRMS. What is virtual voltage? It is nothing but ERMS, right? And we want to find phase difference phi between ERMS and IRMS. And in this particular case the current is wattless. Now as current is wattless, there will not be any power consumed in the circuit and therefore I can say the value of P will be equal to 0, right? So let us start with the solution. Now students, we know formula for average power. The average power in the circuit, or rather true power which is consumed in the circuit, is given by the formula P it is equal to ERMS into IRMS into cos phi. Now over here I am provided with the value of P which is equal to 0 and I am supposed to find out the value of phi in this situation, right? So let us move further. Now as power is 0, so I can write 0 will be equal to ERMS into IRMS into cos phi. Now as current is flowing, so I can say current is not 0. As current is not 0, I can also say that EMF will also not be 0. So I can say in this particular case, value of current and EMF will not be equal to 0. So the only term that can be 0 is cos phi. So therefore I can say cos phi it is equal to 0. And as cos phi is equal to 0, we can say value of phi should be equal to 90 degree. right? So which option is matching? Yes, option D is the correct answer. So from this particular MCQ, we have learned that when the current is wattless, in that particular case, the phase difference between ERMS and IRMS is 90 degree, right? So students, in this particular module, again, we have covered few MCQs which are based on the concept of alternating current. That's it for this particular module. See you in the next module.